EP1100, Data Communication and Computer Networks. In this module, I want to go over the concept of connectivity, topology, and show some network types. Some of the illustrations have been collected from the book by Forrest-Son, Data Communications and Networking, published by McGraw-Hill. Connectivity. Let's assume that the computer in the center can communicate with any of the computers on the right. If it chooses to connect to only one of the computers, we call it unicast or point-to-point communication. An example is an email that's sent to only one receiver. More generally, you can create a multicast by sending to two or more receivers. It's also referred to as point-to-multipoint. It could be an email that's being sent to two or more receivers, or email sent to a mailing list where the mailing system makes sure that all the users on the list will receive the message. We can also generalize the multicast to contain all the computers in the system. Then we talk about broadcast. It's a message received by all. This could, for instance, be an email sent out to all the members of an organization. We can also conceive of a mode called anycast, in which a computer connects to any other computer. But why would you do that? We can also consider the flow of the data. If the communication goes from one computer to another computer in one direction, we talk about simplex communication or unidirectional communication. It means that the receiving computer cannot send an acknowledgement and confirm that the data has been received. This is, for instance, used in broadcasting, where the number of receivers are very many, and the sender would not know what to do with all the confirmations. When both computers can communicate with one another without any restrictions, we talk about duplex or bidirectional communication. Third possibility is what's called half-duplex. It's an alternating directionality where a computer can both send and receive, but not simultaneously. So it either sends or it receives. This is, for instance, the mode for Wi-Fi, for which the radio can either be in transmission and sending mode or in receiving mode. With network topology, we need the structure of the network, how it's connected together with links and nodes. There are four common topologies that we'll review here: mesh, star, bus, and ring. Mesh topology is built by one link between every pair of nodes. The advantage is that it's reliable and robust, because if a link fails, it only affects the communication between that pair of nodes. It has high capacity, because also each pair of nodes has its own link. Disadvantage is that it has a high cost, because you need many links. It's proportional to the square of the number of nodes, and that means a lot of installation cost, and you need I/O ports for each link on each computer. Also, if the communication is predominantly unicast, the links will be used very little, because at any one time only one of the links is used out from a computer. The star topology is much simpler. Each computer is connected into a central node or hub by a single link. It's the common office installation today. It has the advantages of being less costly than a mesh, and it's easy to install and to maintain. But of course, if a link breaks, then the computer is disconnected from the network, and if the hub breaks, then there is no network at all. The bus topology is like a bus line in a public transportation system. It relies on one cable, which is used for broadcasting messages from one computer that will reach all other computers. It's then up to each computer to see whether the message should be received and delivered by them. The advantage is that it's easy to install and has a low cost, but disadvantage is that the cable cannot be made very long, and the maintenance is complicated for reconfiguration and fault isolation. The ring topology is constructed by simplex point-to-point links that connect nodes pairwise in such a way that it forms a closed loop. So when a signal is sent out from one computer, it will circulate around the ring and be able to deliver a message to all the computers around the ring. Advantages are similar to the bus network, that's easy to install and to configure, has a low cost. But of course, if any link breaks, then the whole network is non-functional. It's possible to increase the robustness by having 2 rings and also to get more capacity that way. Networks come in many different forms, and we usually talk about 3 different types: the local area networks, the metropolitan area networks, and the wide area networks. The classification is not very well defined and depends on the size and the distance, the physical architecture, and the ownership of the networks. The local area network is often owned by a single organization which also operates it. It could span a single office, a building, or a full campus, for instance, of a university. It's used for sharing resources such as printers, file servers, and connection to and from the internet. Examples are the wired Ethernet, going up to gigabit per second, and the wireless LANs, the Wi-Fi. Metropolitan area networks do not connect computers directly. They connect the local area networks and other access networks such as the mobile networks. They provide access to wide area networks, predominantly the internet. There are different kinds of ownership. It could be a private company, but most commonly a public company that serves as an operator towards the access network providers. Wide area networks are national and international networks. They could be run by public operators, also known as carriers, to provide commercial communication services globally, or they could also be private networks, for instance the enterprise networks of large corporations. I will provide 3 examples of wide area networks. The historic one is the telephone network, which has been in operation for more than 100 years. It was built for a single killer application, namely voice communication. It's built by very simple cabling to connect customers, called subscribers, to provide transmission of voice signals with low bandwidth, about 3 kHz, which corresponds to the voice spectrum of a human voice. The network was built for low delay so that conversations would flow easily. Data transfer has only been possible by a modem, for instance built into a fax. The communication equipment for the telephone network was simple telephones, and all the intelligence was in the network. The services mainly relate to the connection establishment. You could have a call waiting, you could transfer a call, or you could establish a group call. The second example is cable television networks. These are regional or national networks for the distribution of television signals. The cabling is a very high quality for very high bandwidths, such as coaxial cable or optical cable. The topology is a bus or a star. These networks are owned and operated independently of telephone networks, and they provide competition in the local access to homes and to businesses. The Internet is the most important global communication network. It consists of many interconnected networks, as the name says. They are joined together by a protocol called the Internet Protocol, which means that they have the common addressing and transmission format for the data. Access to the Internet is via the telephone lines in form of digital subscriber loops, via the cable TV network, via fiber to the home, or local area networks, including the Wi-Fi, and more commonly the 3G and 4G mobile communication networks. A company that provides an internet service is usually referred to as an internet service provider, or ISP. The communication services are provided via the World Wide Web, or for mobile phones and tablets, more commonly now directly via apps. The quality of service provided by the internet is a reliable communication, which means that all the data that is sent is going to be delivered completely and in the same order as being sent. There are no delay guarantees for streaming media and gaming.